Hello, this is Dr. Mears, and today we are going to be doing some exponent examples. There should not be an S there, so some exponent examples. And this is working with the rules. If you haven't seen the rules, you should check out the video Law of Exponents, and I quickly review the rules of the law of exponents. So here we have to simplify. That means that we have to make this more simple. We see that we have common bases and we're multiplying. So when we have common bases and we multiply, our rule says to add the exponent so that we could get it down to one base. So one base is base A, and we're going to add 2 plus 5 plus 6, and that's going to give us A to the 13. So 2 plus 5 plus 6 equals 13. Now it's more simple. We went from 3 bases, the same base A's, down to 1, and we just had to add the exponents. Next, here we have 3x squared times 5x to the fourth. So take this step by step. First, just concentrate on your numbers. We know that 3 times 5 is 15. And then cross those out. Now we have x squared times x to the fourth. Same base, we're multiplying, so let's add those exponents. So this is x to the 6. I got 6 by simply adding 2 plus 4. Next, we're now moving into division. When we have division, again, take it step by step. First, divide out the numbers. 12 divided by 2. So that's going to give us 6. It's not going to give us 1 6. It's going to give us 6. You could put a 1 here if you want to do 6 over 1. So we're basically reducing the fraction. That's absolutely fine. So my 12 and 2 are taken care of. What's next? A to the 7 divided by A to the third. Now remember, when we're dividing, A to the 7 divided by A to the third, what we're going to do is we're going to subtract these exponents. That's going to give us A to the 4. 7 minus 3 equals 4. Now, after you subtract, what I want you to do is immediately place it into the numerator spot. Put it in the numerator regardless of what this exponent is. We might get negative sometimes. So right now, put everything in the numerator. It is positive. I'm going to leave it there. Cross out my A's. What do I have left? I have C squared and C to the fifth. So if we divide C squared and C to the fifth, what we're going to do is we're going to take 2 minus 5. Now 2 minus 5 is going to give us C to the negative 3. What did I just say? Put it in the numerator. And I do. I want you to put it in the numerator. So whether it's a positive exponent or a negative exponent, just put it in the numerator. That takes care of the C's. Now the last thing that we have to take care of is any negative exponent. And we do. We have one. This C to the negative 3 is negative. So what we do is we rewrite everything, except because this is a negative exponent, it doesn't belong there. So we're going to put it in the denominator. Once we put it in the denominator, it becomes positive. Next, number 4. We have now powers raised to another power. So what do we do first? First, we put our 1's in. 1 and 1. If you don't have an exponent, put your 1's in. Next, I see that we have this is going to be an exponent of 3. So we are going to be multiplying 3 by every exponent. Feels like distribution. We're distributing that power of 3. So this equals, okay. So first, it's going to be negative 4 to the third. Make sure the negative is in the parentheses because it's in the parentheses here. So in your calculator, when you do that, make sure it's in parentheses. This is going to give you 64. Okay, that's out. Next, P. 1 times 3. Well, that's just P. 1 times 3 is 3. That's out. Q. Q squared. So now we have to do 2 times 3. Q to the 6. Check for any negative exponents. No negative exponents. We're good to go. So little side notes. Put your 1's in for any missing exponent. Number 2, last step. Check for negative exponents. Okay, little side notes. And for number 5, yes, it might look a little complicated, but stick with me. Let's first just, again, take it step by step. So if you have a complicated one, note number 3, start in the numerator. to see if we can simplify anything. So here, 9 is by itself, can't do anything. X to the third, do I have any other x's? Nope, and it does not in parentheses, so we keep x to the third. So I just brought that over, and I brought that over. Now we see we have parentheses here. We have a power raised to a power. So what do? Just like we did here, we can multiply. We need to get rid of these parentheses. That is a goal of ours, to get rid of parentheses. So we do y to the 3 times 3, which gives you y to the 9. Perfect. More simple, no parentheses. In the denominator, let's look. Negative 81. Can't do anything with that. There's no other. If I could, there would be another number to multiply, and there's not. Oh, notice this. We have parentheses. It's going to be x to the negative 2 raised to that fourth power. So you're right. I'm going to multiply. So it's going to be x to the negative 8. Do I have any other y's? I do not, so bring over y to the 11. Again, step by step. We looked at the numerator, then we went to the denominator. Now let's see if I can simplify just 9 over negative 81. And you're right, so it's going to be 1 over negative 9. Negative in the denominator, that's fine. This is just a negative 9. It's not a negative exponent. Okay, what can I simplify next? That takes care of that. X and x, so we're looking for common bases. That could be another note. Look for common bases. All these things I pick up is because I've done these so many times. And if you practice over and over, you get good as well. So we have division here, common bases in division. So that means we're going to take the numerator, 3, the exponent in the numerator, minus the exponent in the denominator, negative 8. This was a negative 8. We still subtract a negative 8. But you're right, this really turns to x3 plus 8, and this is x to the 11. Now, where does it go? It goes in the numerator. Always put it back in the numerator. That could be another note if you want to add. After you subtract, always put in the numerator. So that's out. Okay, next one. Y to the 9. I have division. I have common bases. What do we do with the exponents? We subtract. So 9, the numerator always, minus the denominator, 11. So 9 minus 11, y equals negative 2. Put it in the numerator, negative 2. So 5, put number back in numerator. Okay. All right. What do we have to do now? What do we see? Last step, check for negative exponents. Do I have a negative exponent? Yes. So let's rewrite this. The x is fine. You can put the 1 there. That's fine. The negative 9 is 5. This negative is not in the exponent spot. It's just in front, which is okay. Y to the negative 2, does it belong in the numerator? No. So we're going to put it down in the denominator, where then it would go change to positive. Okay. Next, fractional exponents. Here is a new rule for you. And what this does is it's going to help us to get rid of parentheses, and it's going to help us write our roots and our exponents as fractions. So what do I mean? So this is how it's stated in the book. This is how I like to explain it. So this is a root. So usually if you see this is a square root. If you see this is a cubed root. Taking the cube root, or the fourth root. We can keep going on and on. But this number right here, that's called the root. And then we have our variable inside. And we can have the variable raised to an exponent. So I'm going to use the letters R and E. And when you take this root symbol away, we can change this into a fraction. So what we can say is a raised to the e over r. So whatever number the exponent is the numerator part of your fraction. Whatever root you have is the denominator. Let me show you an example of this with number 1. Without the use of technology, no calculator, find the value of 8 raised to the 2 over 3. So let's assign our letters. This is the exponent, and this is the root. So let's rewrite it using our little bar here. So this is the exponent, 8 squared, e. Root is 3. So that's the cubed root. First, let's actually do 8 squared. So this we're doing the cubed root. 8 squared is 64. Now what the root is asking you, it's asking you what same number 3 times itself will give you 64. 2 times 2 times 2 is 8. Won't work. 4 times 4 times 4, that works. That's 64. So this answer is going to be 4. So what this is asking is what number 3 times itself will give you 4. That's this whole symbol. That's the long English version of saying the cube root of 64. What number 3 times itself gives you 64? That's what this is asking. Now, if you had the 4th root, it'd be 4 times itself. 5th root, 5th times itself. 6th root, 6 times itself. It could go on and on. You're used to square root, and you're also used to not seeing this 2 here. I actually wish we would write it in. That would make learning these a little bit easier, but it does like to hide. So this is actually asking you what number 2 times itself, 3 times itself, so on and so forth. Now we can also use this rule to write this in an exponential form. Exponential form is the same thing as writing it in a fraction exponent. Remember, we like to use the same concept but assign different words to it. So if I say exponential form, I want the exponent as a fraction. So here we have, this is e exponent, this is root r. So it's going to be x to the exponent over the root, and that's it. If you have a hard time remembering which one goes on top, remember E comes before R in the alphabet, so E is the one you write down first, which is the exponent. So that's exponents. Now, I also promised a video on simplifying square roots. And if you're in my class, you also got a copy of perfect squares. So I want to talk about these because it does go along with our taking a cubed root and 4th root and square root. So remember, these are all square roots. Usually the 2, we would see a 2 written in, but again, they like to make it disappear here. So what makes these perfect squares is that though this has a number multiplied by itself, these don't come out in decimals. So if you take the square root of 4, we're going to get 2. We're not going to get a decimal answer. It wouldn't be perfect if we got a decimal. So what number 2 times itself gives you 1? 1. What number 2 times itself gives you 4? 2. What number, same number, 2 times itself gives you 9? 3. And notice no square root is written. That's it. This is simply the question, what number 2 times itself? That's what this means. What number 2 times itself gives you blank, whatever is underneath that square root. So 64, 2 times itself, 8 times 8. There we go. 81, 9 times 9. There you go. So that's all that's asking. So you can keep this sheet because it's going to make our work here a little bit easier. Because when we simplify square roots, what we have to do is we have to break the square root down into 2 different ones. This first one is going to be a perfect square. And this one is going to be what's divided out. What do I mean by that? Okay, so which one of these perfect squares can we divide 12 by? Try to find the largest. Well, I don't think we can do 9 because 12, we can't divide 12 by 9. Can we divide 12 by 4? Yes. So the perfect square that we can divide 12 by is 4. Well, 4 times what gives you 12? You got it, 3. So we have to take this apart so that one part is the perfect square and the other part is whatever we have to multiply to get back to. So 12 divided by 4 is 3. Now what we do is, can we take the square root of 4? Is it a perfect square? Yes. So this is going to be 2 times the square root of 3. We just write it just like we would say 2x, we just attach it together. And so this is taken as this is multiplication, because remember, 4 times 3 to get back to 12. So it's just 2 times the square root of 3. We can't divide anything out, so this is now more simple. We took out the perfect square. That's what it means by simplifying, dividing out the perfect square. Divide out the perfect square. Okay, so let's try number 2. All right, so we have to do 1, 2. All right, this one's going to be the perfect square, the biggest one. This one is going to be what we need to multiply to get back to, whatever we divide that by. Okay, so let's look. Well, we know 34 can go into 32, but there's a bigger one. And you're right, it is 16. Okay, so 32 divided by 16 gives you 2. So if we multiply these, we get back to 32. Okay. Can we take the square root? Absolutely, it's a perfect square. That's why we did this. 4, attach this, square root of 2. Done. So it really is looking for the perfect square, which makes this sheet, if you want to screenshot this so you have it on your computer or your phone as well, there you go. Okay, let's try number 3, 50. So largest perfect square and whatever we have to multiply to get back to 50. So you got it. It's 25. 25 times what? 2. 25 times 2 gets you back to 50. This is multiplication. What's the square root of 25? 5. Square root of 2. Please notice I didn't write 2 square roots, just this one. And if you want to try this one, you can on your own. I'm just going to say the perfect square and what we have to multiply. So you're right, it's 4 and 2, because 4 times 2 is 8. So this is going to be square root of 4 is 2 times the square root of 2. Be careful, you can't go any further. Remember, underneath the square root, 2 is not perfect. 1 is, but not 2. So this has been a mixture of some examples. Hopefully you're starting to understand the root better, especially with cubed roots and fourth roots and our new fractional rule. And so this has been working with the rules and some exponent examples. Thank you.